Good day, everyone. So today we're going to discuss about the 7 different limit theorems. So first, let us know what limit theorems are for. Limit theorems are used to evaluate limits which are functions. So the first limit theorem states that the limit of a constant as x approaches a is equal to the constant. The first example that we have for the first theorem is the limit of 8 as x approaches 3. The first thing you need to do in this theorem is identify what the constant is. In this problem, the constant that is given is the number 8. So, as stated, the limit of a constant as x approaches a is equal to a constant. So, the answer here is 8. The second example is the limit of 0 as x approaches 10. So then again, you identify what the constant is, and the constant is here is the 0. So the answer is 0. In the last example, the limit of 1 as x approaches 8 is equal to the constant, and the constant is 1. So the answer is 1. In the second limit theorem, it is stated that the limit of x as x approaches a is equal to a. So the first example for this theorem is the limit of x as x approaches 1/2 is equal to what? So in this theorem, you need to identify what the variable a is. And in this problem, a is represented by the number 1/2. So the answer here should be 1/2. In the second example, the limit of x as x approaches 100. So again, you need to identify the variable a, and here it is represented by the number 100. So the answer is 100. And in the last example, the limit of x as x approaches 34 is equal to 34. In the third theorem, it is stated that the limit of a constant times a function as x approaches a is equal to the constant multiplied to the limit of f of x as x approaches a. In the first example, is the limit of 3 of x as x approaches 3. So we'll apply the first theorem and the second theorem in the third theorem. First, you need to identify what the constant is, and here it is the number 3. So you write 3 and multiply it to the function, and the function is x. This is the constant and this is the function. And the next thing you'll do is apply the second theorem, where you'll substitute the value of x to the with the value of a. So the answer in this example is 9, because if you multiply 3 with the number 3, you'll get 9. In the second example, the limit of 5x squared as x approaches to negative 2. Again, apply the first and second theorem. Identify what the constant is. And in this problem, it is the number 5 times the limit of x. And in the second step, you'll use the second theorem. You will substitute the value of x with the value of a. And then you will solve for this. The answer for this problem is 10, because 5 multiplied by 2 is equal to 10. In the third and last example for this theorem, the problem is the limit of 10x cubed as x approaches 7. Substitute the value. So you solve for 7 cubed, and the answer is 1 times 333. The answer for this problem is 3,430. In the next limit theorem, it is stated that the limit of the sum of the functions f of x and f of g is equal to the limit of x, the limit of f of x as x approaches a plus the limit of g of x as x approaches a. So for the first example, the limit of x squared plus 3x as x approaches 1. In this theorem, we will get to apply the first 3 theorems that I've discussed. First is to move the constant, arrange them. X1, X2, X3 times limit of X1, X. In the next step, you will use the third theorem and the second theorem. Substitute the value of x. Squared plus 3 times 1. And then you will solve. And the answer will be 4. Four plus 9. You solve. Negative 4 plus 9 is equal to 5. So the answer for this problem is 5. In the last example for this theorem, the problem is the limit of 12 plus x cubed as x approaches 2. Arrange the limit of 12 which is 2 plus the limit of x cubed which is 2. Then substitute the value of x. Then plus 2 plus 2 cubed. 2 cubed is equal to 8. 12 plus 8 is equal to 2. So that's it for this theorem. The next theorems will be discussed.
So now we are going to be learning the 5th, 6th, and 7th theorems and the limits. So the 5th theorem is the limit of the difference of f of x and g of x is equal to the limit of f of x minus limit of g of x as x approaches to a. So here we have our first example, the limit of 3x minus 9 as x approaches to 4. To rearrange this, refer to the theorem 3. So let us now arrange this one. So the coefficient will go first, and then the limit second, and the variable, and you put limit beside the 9. And don't forget to put the x approaches to 4. After this, you substitute the value of 4 to the given problem. So let us substitute. This will be 3 times 4 minus 9, and then apply first the 3 times 4, which is 12, minus 9, and the answer is 3. Moving on to the second example, the limit of 3x squared minus limit 4x as x approaches to 2. again arrange. So 3 lim x squared limit x as x approaches to 2. So now we can solve by substituting the value of x. So 3 times 2 squared minus 4 times 2. So evaluate. So 3 times 4 minus 8. We evaluate. 4 times 3 equals 12 minus 8. Now the answer is 4. Last example. The limit of x minus 5 as x approaches to 10, and we should add limit to the other side, which is the negative 5. So limit x minus limit 5 as x approaches to 10. Solve by substituting the value of x, which is 10 minus 5, and the answer is 5. The next theorem, which is the sixth theorem, is the limit of the product of f of x and g of x, which is equal to the limit of f of x multiplied by the limit of g of x as x approaches to a. So example A, which is the limit x multiplied by x plus 9. So you add the limit to the other side like this. Multiplied by limit x plus 9 as they both approach to 2. Now let us substitute the value of x. So 3 multiplied by 3 plus 9. Evaluate. 3 multiplied by 12 is equal to 36. Example B. The limit of 3 of x is multiplied by 4x. So again, refer to Theorem 3 to rearrange the function. So 3 limit of x multiplied by 4 limit of x as the x approaches to 2. So substitute the values of x, which is 2. So 3 multiplied by 2 times 4 multiplied by 2. Evaluate. 3 times 2 equals 6. Multiplied by 4 times 2 equals 8. And the answer is 48. Then the last example is the limit x squared plus 3 multiplied by x plus 5. So again, we arrange limit of x squared plus 3 multiplied by limit of x plus 5 as the x approaches to negative 2. Okay, now let us substitute the values of x, which is negative 2. So, negative x, negative 2 squared plus 3 multiplied by negative 2 plus 5. We evaluate the exponent. Negative 2 times negative 2 is equal to positive 4 plus 3 multiplied by negative 2 plus 5. So we will get this 7 multiplied by 3, and the answer is 21. The last theorem is the limit of the quotient f of x over g of x is equal to the limit of f of x divided by the limit of g of x as x approaches to a, provided that the g of x is always not equal to 0. So let us move on to the first example. Theorem 3 should still be used in this theorem to rearrange. So let us do this. First off, the f of x at the top you arrange. So 2 limit of x plus 4 divided by 5 limit of x minus 9 as they both approach to 3. So we have arranged, and then now let's substitute the value of x to the f of x and g of x to look like this. 2 multiplied by 3 plus 4 divided by 5 times 3 minus 9. You will get the answer like this. 2 times 3 equals 6 plus 4 equals 10, and 5 times 3 equals 15. Subtracted by 9 is 6. Then simplify, and you will get 5 over 3. This will be your final answer. Moving on to the second example, the limit 2x over 4. Again, we arrange as done in theorem 3. So 2 limit of x as x approaches to 8 is divided by 4 as x approaches to 8. Now let us substitute 2 multiplied by 8 over 4 is equal to 16 over 4. When simplified, you will get 4. And this is gonna be your final answer. And now the last example, which is the limit x plus 9 over the limit x minus 3. Now there's no need to arrange because there is no coefficient aside the variable, so let's just put the word abbreviation limit aside the variable. Limit x plus 9 as x approaches to 5 is divided by limit x minus 3 as x approaches to 5. You can directly substitute the value of x, which is 5. It will look like this. Limit of x is substituted by 5 plus 9 over the limit of x is substituted by 5 subtracted by 3. Five plus 9 is equal to 14, and 5 minus 3 is equal to 2. When simplified, you will get the answer of 7. That's all. Thank you.